Hey, how's it going? Master Cal here, math expert for the AA Discord server, and today I'm going to be giving a review/tutorial on linear equations. So this is an Algebra 1 topic, and this topic deals in the two-dimensional world. And you may remember from elementary school that a two-dimensional surface is known as a plane. A plane has infinite length, infinite width. It has essentially no thickness. It's just two-dimensional, and that's where lines and points reside. So we're dealing with a very special kind of plane, and it is called a Cartesian plane. It looks like this. Right here, moving up and down, we have a line, and moving left and right, we have a line. This is called here the y-axis, and this here is the x-axis. So they are perpendicular to each other, and they intersect right here. At this point, it's known as the origin. And inside this Cartesian plane, there is an infinite number of points that can reside. The origin here is just one of them. And so how do you delineate points? Well, it's like this. A point is written as an ordered pair, and you write the x-coordinate first, and then you do the y-coordinate second, like this. You put the numbers in for the variables. So that's how it goes. And there's also a sign convention that I will show you right here. And how it goes, it is right positive and up positive. So as you move to the right along the x-axis, the values get larger. If you're on this side over here, it's negative. And if you're over here down below, you have a negative y value. Up here, you have a positive y value. So you can end up dividing this coordinate plane into 4 parts called quadrants. This is quadrant 1, and quadrant 1 is positive and positive for any point in this quadrant. Then over here is quadrant 2. In quadrant 2, you are up on the y-axis and you are to the left on the x-axis, so that means it's negative and positive. Down over here is quadrant 3. Quadrant 3 is to the left on the x-axis and down on the y-axis, and so that means you have 2 negative values. Both the coordinate values are negative. And then this here is the 4th quadrant. These are in Roman symbols, by the way, if you don't know. We're right on the x-axis, we're down on the y-axis, so we're plus and negative. So this is the sign convention that we're going to use. If you have a point that's on one of the axes, then whatever axis it's on, it's 0. So if you have a point right here, actually, sorry, no, that's backwards. If you have a point right here on the x-axis, its y value is 0. And if you have a point on the y-axis, the x value is 0. And obviously, then the origin, with an O here, that is just 0 and 0. So if I were to plot the point, say, 2, 3, I would go 2 spaces over here. Well, it's 1 space because of how Desmos is. And then up 3. So somewhere around here would be the point 2, 3. Yep, so that's 2, 3. Let me put these on. So this is the point 2, 3. If I wanted the point, say, -2 and -3, we would go left 2 units and down 3 units, so about here. And we can check that. And, oops, wrong spot. There we go. -2, -3 is right here. So these are points. And then next we'll deal with lines. Lines are infinitely long. They go in both directions, and they lie on this plane. There is exactly one line that is going to connect these 2 points. So the question becomes, how do we determine what that is? Well, we'll figure that out. So the first thing, so now I have to introduce to you the concept of slope. Now slope is a measure of how steep a line is, and how basically how the y variable changes with how the x variable changes. So slope is written as m, and how you determine the slope, m is equal to rise over run, and in mathematical terms, it's y2 minus y1 all over x2 minus x1, where x1, let me just do this just for clarification, x1 and y1 is a point, and you have x2, y2. So that's how you determine the slope of a line. Slope can be positive or it can be negative. Slope is positive if x increases, or if x and y are both increasing, or they're both decreasing, then it's a positive slope. But if the y is increasing as the x decreases, or the x or vice versa, then it's a negative slope. You can also have a zero slope, and an example of a zero slope is going to be this line here, the x-axis, and any other line that is up or below it, and that is just flat. That's because the y value, if you notice, does not change. So right here, you have 0, 0, and 0, 2. You have 0 minus 0, which is 0, and you have 0, then you have 0 minus 2, which is negative 2. So 0 divided by negative 2 is 0. And by the way, it does not matter which order you choose the points in. I could have said 0 minus 0 and then 2 minus 0. 0 over 2 is still 0. And that applies for anything. You can choose 2 points. It does not matter which one you say is the first point, which one is the second point, just as long as you don't mix it up. So for example, I can't say that like this 2 here is my x1, but this negative 3 here is my y1, because those are 2 different points. You have to keep them consistent, but it doesn't matter in ultimate which order you do. So if I were to find the slope of the line that passes through these points, I would say m is equal to, I'm just going to take the first one as my first point, so I'm going to have negative 3 minus 3, negative 3, sorry, minus 3, it's not supposed to be a comma, over negative 2 minus 2. Negative 2 minus 2, which gives me negative 6 divided by negative 4, which becomes positive 3/2. Now I can check and confirm that if I did it the other way around, that'd be the same answer. I'd have 3 minus negative 3, and then I'd have 2 minus negative 2 right here, which becomes positive 6 over positive 4, which is also positive 3/2. I got the same answer. And that makes sense. Okay. And that makes sense because if you look over here, as the x value is increasing, the y value is increasing. So now we're going to talk about the different forms of a line that exist. So there are several different ones, and the first form is point-slope form. And point-slope form is y minus y1 is equal to m times the quantity of x minus x1. So m is just your slope, and then x1 and y1 is just a point. So for the line that would connect those 2 points, I could say y minus -3 becomes y plus 3 is equal to 3/2 times, I have x minus -2 becomes x, or yeah, minus -2 becomes x plus 2. And again, for this one, it doesn't matter which point you choose as long as it's on the line, and as long as you keep it consistent. So if I enter that in here, you give me a second to do that. There, you see? This green line here is connecting these 2 points, and that's how it goes. And if you wanted to express the slope in terms of rise over run, you would go, the rise would be 1, 2, 3, 4, 5, 6, and then your run would be 1, 2, 3, 4. 6 divided by 4 is 3/2. So that is the point-slope form of a line. The next form is slope-intercept form. And slope-intercept form says y is equal to mx plus b. Now what is b? B is a component that's known as the y-intercept. And the y-intercept is basically where the line crosses the y-axis. So in this case, the line crosses the y-axis at 0. So in this case, you could say that this is equal to y is equal to 3/2 x. 3/2 x. That's another way of writing the equation of this line. And we can check that. So if I expanded this one out, I'd get y plus 3 is equal to 3/2 x plus 3/2 times 2 is 6/2, which becomes 3. Then if I subtract the 3 out, I get y is equal to 3/2 x. So that was an easy example, obviously, so I'm going to just make up another line here. I'm going to say y is equal to, how about 2x minus 3? So the purple line right here. Notice that this is a point 0, 3 on the line. So basically, there's only one of these that exists for any given line, and it's where the line crosses the y-axis. It's where the x-coordinate is 0. So again, that equation is y is equal to 2x minus 3, which means your slope is 2 and your y-intercept is 3.